You know that feeling when you're caught in a really bad windstorm? The kind that just howls and feels like it's trying to tear the world apart? Well, today we're going to go find the most extreme winds ever recorded. And trust me, they make a hurricane on Earth feel like a total whisper. Okay, let's get into it. So this is it. This is the big one for planet Earth. 408 kilometers per hour. That was the single most powerful wind gust ever measured on our planet's surface, all the way back in 1996 during Tropical Cyclone Olivia. I mean, that's enough to rip buildings to shreds. It is the absolute peak of nature's fury, right here at home. And yet, and this is the crazy part, in the grand scheme of things, that terrifying record-breaking gust, it's literally nothing, just a light breeze. To find the real heavy hitters, we have to leave our little blue marble far, far behind. So here's the game plan. We're going to start with what we know here on Earth. Then we'll visit the solar system's long-reigning champ. I'll show you how we can actually measure wind on planets light years away. And then we'll meet the new, absolutely mind-blowing record holder. We'll figure out what's powering these insane storms, and finally, why any of this really matters. All right, first up, before we can really wrap our heads around the kind of cosmic extremes that are out there, we have to start with something we can actually relate to. We need a baseline. So, what even is wind? When you boil it all down, it's just an atmosphere trying to find its balance. You see, energy from a star heats up one part of a planet, and the atmosphere's job is to move that heat from the hot spots over to the cold spots. That movement? Well, that's wind. Simple as that. Okay, now let's take a trip. We're headed out to the cold, dark edge of our own solar system. For more than 30 years, this distant blue giant was the undisputed king of storms. Say hello to Neptune. And this just puts it all into perspective. Just look at this. Earth's all-time record of 408 kilometers per hour, it's that tiny little sliver on the left you can barely even see. Even the mighty Jupiter, with its famous Great Red Spot, gets totally blown away. Neptune's winds, topping out at over 2,000 kilometers per hour, they're just on a whole different level. And let that sink in for a second. We're not just talking about fast winds. These are supersonic winds. They are moving so fast, they actually break the sound barrier in Neptune's freezing atmosphere, just whipping these clouds of frozen methane around the planet like cosmic shrapnel. But here's the big mystery that had scientists scratching their heads for years. Neptune is so far from the sun. It's ridiculously cold and dark out there, and it gets almost no energy from the sun. So, where in the universe is it getting the power to drive supersonic winds? And the answer, it turns out, is coming from the inside. Neptune is like its own simmering cosmic furnace. It actually gives off more than double the energy it gets from the sun, all powered by leftover heat from when it was first formed billions of years ago. This internal engine creates these massive, swirling currents that, because there's so little friction in the atmosphere, can just accelerate to these unbelievable speeds. So for 35 years, Neptune's record just seemed unbeatable. To find something faster, we have to look way beyond our own solar system, out to exoplanets. But think about it. How do you possibly clock the wind speed on a world that's just a tiny speck of light trillions of kilometers away? Well, scientists use this incredibly clever trick. When an exoplanet passes in front of its star from our point of view, some of that starlight has to pass through the planet's atmosphere. The gases in that atmosphere absorb very specific colors of light, which creates a sort of unique barcode for that planet. And by measuring tiny, tiny shifts in that barcode, caused by the winds moving towards us or away from us, astronomers can actually calculate the wind speed from light years away. It's amazing. And it was using that exact method that astronomers recently aimed some of our best telescopes at a very, very strange exoplanet. After all those decades of Neptune holding the title, it was finally time to crown a new champion. Yeah, ever since the Voyager 2 spacecraft flew past it in 1989, Neptune has been the gold standard, the benchmark for what we thought extreme weather was. But that benchmark was about to get completely shattered. So fast forward to January 2025, a team using the Very Large Telescope down in Chile announces a new finding. And it didn't just break the record. No, it totally obliterated it. Get this, 33,000 kilometers per hour. That is over 9 kilometers every single second. It's 16 times faster than the winds on Neptune and more than 80 times faster than the most violent gust ever felt here on Earth. This is the new record, found on an exoplanet called WASP 127b. The lead researcher on the project, Leonard Norman, he put it perfectly. He said this is something they just haven't seen before. It's officially the fastest wind ever measured in a jet stream that goes around a planet. A whole new class of violent. So that leads to the biggest question of all. How? How is it even possible for a planet to generate winds this ridiculously fast? Well, it turns out we've now found two completely different kinds of engines that can cook up these cosmic storms. And what's so cool is how different they are. Neptune, like we saw, is powered from the inside out. It's got that deep internal furnace doing all the work. But WASP 127b, it's the complete opposite. It's powered from the outside in. Its engine is the intense, scorching radiation from its star, which basically acts like a giant blowtorch on its atmosphere. And the secret to WASP 127b's insane winds is what it's made of, or really what it's not made of. It's what scientists call a puffy gas giant. So it's physically huge, bigger than Jupiter, but it has way, way less mass. That makes its atmosphere super low dense and spread out, which is the perfect canvas for its star's energy to grab onto and accelerate into this hyper-efficient, record-shattering wind system. Look, finding a new number for the cosmic record books is always fun, right? But these discoveries are so much more than just trivia. They really do change how we think about the way planets work across the universe. When we study these wild extremes, we are pushing the absolute limits of physics. Every time we get a new data point, like the winds on WASP 127b, it helps us make our models better for understanding all kinds of other worlds, maybe even worlds that could support life. It just goes to show you that the universe is way more diverse and creative than we ever could have imagined, and that sometimes the weirdest planets are also the most violent. So we kinda end right where we started, just in total awe. We went from a 400-kilometer-per-hour wind gust here on Earth to a 33,000-kilometer-per-hour jet stream hundreds of light years away. It really just leaves you with one final, exciting question. If that's what we've managed to find so far, what other, impossibly faster worlds are still out there, just waiting for us to discover them?